Hi everyone, this is Sindhuja Reddy from Mlritm College, Dundigal. I am working as an assistant professor. So today I am going to explain the topic related to the flat. The flat is nothing but a formal language and automata theory. In this subject, I am going to explain regular expression. So last class we discussed what is the how we are representing the alphabets, how we are converting the DFA to NFA and NFA to DFA. So today I am going to explain the what is regular expression. So what is regular expression? So what is regular expression? The regular expression is a sequence of characters. A regular expression is a sequence of characters that forms a specific search patterns. That forms a specific search pattern. Means it is used to form a pattern by using star, dot and epsilon and union, concatenation, plus, minus. These are the specific operators which is used in the regular expression. So by using this regular expression, it is used to describe regular languages. Regular languages are commonly used for validating, searching and parsing. Means if you want to validate any data, the regular expression is used, and if you want to search any text or audio, it is used to convert from text and audio into the data. So in this we have some rules. So before going to the rules, what are the regular expression is also represented as a regular language. The regular expression is also represented as a regular language. So we have some rules. The first one, that is the epsilon. So if epsilon is a regular expression, it will be represented as regular language like a flower bracket epsilon. Flower bracket epsilon means the whenever the in the flower bracket the epsilon occurs, it is known as a empty set. It is known as a empty set. The first rule is if the regular expression uses epsilon, then the regular language is flower brackets epsilon, means it is the empty set. The second rule is if any symbol A is a input symbol, then the alphabet symbol is sigma. The alphabet symbol is sigma. So this sigma is a regular expression. It will be represented with the flower bracket A. The regular expression should be represented with the flower bracket A. The next one, union. All of you know the union is a combining the two sets into the one. So here A plus B is a regular expression. If A and B are regular expression, it should be represent in a language in the way of flower bracket A comma B. Next, the concatenation. The concatenation is a regular expression. If A and B are the regular expression, clean star is a clean star, and clean star is a regular expression. Zero or more occurrence means whenever we occur star, here it should be zero or more occurrence. Zero or more occurrence of A's means here A star, it represent any number of A's, any number of A's, any number of A's. For example, A star B, A star B. We can write this as a set A B, A B means the star represents any number of A's. If suppose we have A star and B star, it should be any number of A's and any number of B's. So here we have only A star and B, means any number of A's, but B is 1. So the rules are epsilon. Whenever the epsilon represent the regular expression, then the language is empty set. If A is the input symbol, then the regular language is flower bracket A. A union A plus B. A and B is represented as a regular language, flower bracket A comma B. And concatenation, it is nothing but a dot B. A dot B. If A and B are regular expression, then here the clean star, here it may be dot and star are the zero or more occurrence of a expression in a regular language. So here the regular expression, we have a tabular form for any number of A's and any number of B's. Suppose the set of ovals. What is ovals? A, E, I, O, U. Ovals is A, E, I, O, U. So here it contains with the bracket A hyphen, means the regular language is epsilon. The regular language is epsilon. A followed by Z. A followed by 0 or more B's, means A followed by 0 or more B's, means A and A is nothing but a 0. A is nothing but a 0, but it is followed by the B star, means A is a 1 and B is n number of B's, means A star B means n number of A's with 1 B. Here A B star means 1 number of A with n number of B's. Next, any number of vowels followed by any number of consonants, means here in this statement any number of vowels means A, E, I, O, U. It may be followed by any number of consonants. Any number of consonants means the star in this regular expression, the important is star, union, concatenation. Union is nothing but a plus. Concatenation is nothing but a star. So epsilon is nothing but an empty set. These three are the main rules which are used in a regular expression. So after this regular expression, we need to know how to convert the finite automata to regular expression, from finite automata to regular expression. So here we have 4 steps in converting finite automata. So first step, construct state equation for all the states based on incoming edges. Means the state, suppose we have A, capital B. So first one, construct state equation for all state based incoming edges. Suppose A is sending B. So first, A, construct state equations for all the state based on incoming edges. The B is sending B to the A, means the A contains the incoming edge from the B, means B dot B. Next, B. A dot A. For every state, you need to construct the incoming edges. And the second step is add epsilon to the equation to initialize. Add epsilon to the initial state. Next, it contains 2 methods. One is Adam's theorem and the next one is indirect method. Adam's theorem or Adam's method or indirect method. So the third step is simplify the equation using Adam's theorem. So the Adam's theorem is R is equal to Q plus RP. The next one, the simplification of this one is R is equal to QP star. So the result is the value of final state. The result is the value of final state. And we need to do the simplification for the final state only. So again I am explaining this one. This fourth step is very important in this topic. Conversion of finite automata to regular expression. The first one is, for every state you need to construct the incoming edges. Construct all the state based incoming edges. Add epsilon to the initial state and simplify the equation by using Adam's theorem or Adam's method. The fourth one is, the result is the value of final state. So let me know what is the process of the problems. I have taken two problems. First one, Q1 is the initial state and it is sending the B to the Q3. I am doing this problem. Please watch. Q1, B, Q3, A, Q2, A, A. The first problem is this one. So here the first step, construct all the states, construct the state equation for all the state based on incoming edges. So first step is Q1 is equal to, the Q1 does not contain any incoming edges. The Q1 does not contain any incoming edges. Means here we need to write epsilon. Why? In the second step, we need to add the initial state to the, we need to add epsilon to the initial state. Next one, Q2. Q2 is Q1 dot A. The incoming edge is from Q1 to Q2, we are sending A. Q1 dot A plus, that's it. Next, Q3. Q3 is Q1 dot B plus Q2 dot A plus Q3 dot A. Q3 dot A. So here the final state is Q3. The final state is Q3. So here I am substituting the epsilon, equation 1, equation 2, equation 3. So here from using equation 1 in equation 2. So Q2 is equal to epsilon A. Next, Q2 is equal to epsilon dot A. Next, substitute equation 1 and 2 in equation 3. 1 and 2 in equation 3. Q3 is equal to epsilon dot B, because the Q1 is epsilon. Epsilon plus dot B plus Q2 means Q1 dot A. Again here we have A plus Q3 dot A. Q3 dot A. Q3 dot A. B plus A dot A. Q1. plus Q3 dot A. Here, using Adam's theorem, what is Adam's theorem? R is equal to Q plus RP. R is equal to QP star. R is equal to QP star. R is equal to QP star. This is here. This is Q R P. Q R P. Q is B plus AA. R is equal to B plus AA. R is equal to Q. Q ante entidi B plus AA. P star is A star. This is the regular expression of this problem. So here again I am explaining this problem. First, construct all the state equations for all the state based incoming edges. So we need to start from the initial state. Q1 is equal to, we need to check any incoming edge for the Q1. So here don't have a incoming edge. So after that, second step is we need to add epsilon to the initial state. So that's why Q1 is equal to epsilon. Next, Q2. Q2 is equal to, the Q2 contain Q1 dot A. Next, Q3. Q3 is, from Q1 it contains the incoming edge, Q2 it contains the incoming edge, and itself it is also have a incoming edge. So using equation 1 and 2, it is the Q2 is equal to epsilon dot A. So epsilon dot A is epsilon dot A. So substitute equation 1, equation 4 in equation 3. So Q1 is Q1 dot B. Q1 is epsilon dot B plus epsilon dot A dot, again here we have A plus Q3 dot A. Epsilon A plus A, here epsilon I am taking, anything into epsilon into anything, that anything only. So B plus AA plus Q3 dot A. Here by using Adam's theorem, R is equal to Q plus RP. It will be simplified way. R is equal to QP star B plus A star. This is the regular expression for this problem. Hope you understand this problem. Once do the practice and you will get the answer very easy. Conversion of finite automata to regular expression. The second problem we need to do with me. I will explain. Second problem, Q1, Q2, Q3. Q1, Q2, Q3. Q1 is final state, B, A, B, B, A. So Q, A. So this is the problem. Second problem, step 1. Step 1 is For all the state equations, we need to write the incoming edges. So Q1, let's start with Q1. Q1 is equal to Q1 dot A plus Q3 dot A. Q1 dot A plus Q3 dot A. Next, Q2 is equal to Q1 dot B, Q2 dot B plus Q3 dot B. Q3, Q2 dot A, Q2 dot A. Second step is add epsilon to the initial state. Add epsilon to the initial state. Add epsilon to the initial state. Now, we need to use, or you need to convert or simplify the equation by using Adam's theorem for the step 3. So here we need to result from the Q1. So here Q1 is equal to Q1 dot A, Q3 dot A. But Q3 is a Q2 dot A. Q2 dot A. So before we have to perform the Q3, we need to perform Q2 because directly or indirectly the Q3 is connected with the Q2. So equation 1, equation 2, equation 3. So using 3 in 2. So using 3 in 2. Q3 is equal to Q1 dot B plus Q2 dot B plus Q2 dot AB. Here we substituted Q3 in the place of Q3, Q2 dot AB. So here Q3 is equal to Q1 dot B plus Q2. Q2 for common this day. Here B plus AB. Q plus AB. So Q3, Q2. So we need to substitute this form into the equation 1. Substitute equation 4 in equation 1. Q1 is equal to Q1 dot A plus Q2 B plus AB dot A. R is equal to what is Adam's theorem? R is equal to RP plus Q. R is equal to QP star. Means Q1 is equal to Q2 B plus AB dot A, B plus AB dot A. P star means A star. P star is A star. Means here substitute equation 4 in equation 1. Here after substituting we need to perform Adam's theorem. So Adam's theorem is R is equal to RP plus Q. R is equal to QP star. Q1 is equal to Q2 B plus AB into A star. So here we need to substitute Q2 in the place of Q2. Fifth equation 5. Equation 5, substitute in equation 2. Q1 is equal to Q1 dot B plus, in the place of Q2 substitution, Q2 B plus AB, A star plus Q2 dot A. Q1 is equal to Q1B plus Q2 B plus AB, A star, again A star, again A star. So this is in the form of Q1 is equal to B plus A, B, A star, A star. This is the regular expression of this problem. So thank you. Hope you like it.